Welcome back to The Explainer. Today, we're going to look under the hood of a really cool AI framework called ReAct. It's all about teaching AI to, well, think before it acts, kind of like we do. And this simple idea is making AI way smarter and a whole lot more reliable. So let's just jump right in with a question that honestly gets to the heart of a really weird contradiction with AI today. How is it possible that an AI can write this, beautiful, complex poem, but then totally fail at answering a simple, factual question without just making stuff up?
It's this weird split personality, right? On one hand, you've got these incredible superpowers. I mean, they have access to just a mind-boggling amount of knowledge, they understand complex language, but then, on the other hand, they've got this critical kryptonite. They suffer from what researchers call fact hallucination, which is a fancy way of saying they just make stuff up. And then there's error propagation, where one tiny mistake can snowball and lead to a completely wrong answer. And sometimes they just get stuck. They can't figure out how to solve problems that have multiple steps.
All right, so here's how we're going to break this down. First, we'll dig a little deeper into that big contradiction. Then we'll look at how we humans think and act, which is actually the inspiration here. After that, we'll introduce ReAct itself, see it in action, and talk about why it's such a breakthrough. And finally, we'll look at what this all means for the future of how we work with AI.
Okay, so first up, let's take a closer look at this core contradiction. Why are even the most powerful AI models so surprisingly flawed?
And this quote from the research paper really nails it. AI reasoning is often a static black box. What that means is the model is just thinking inside its own head. It's not actually checking its thoughts against the real world. And that's exactly why it can just invent facts out of thin air or let a small mistake spiral completely out of control. It never stops to, check its work.
So what's the solution? Well, brilliantly, it doesn't come from just throwing more computing power at the problem. It actually comes from looking at how we, you and me, solve problems in our everyday lives.
Yeah, just think about something as normal as cooking a meal. There's this constant, seamless flow between your inner monologue, what you're thinking, and your physical actions. You don't just follow a script, right? You adapt.
It goes something like this, right? First, a thought. I need the pepper shaker. It's probably in one of the cabinets. That thought leads to an action. You open a cabinet. Then comes the observation. Nope, no pepper shaker here, just a vase. And that observation immediately updates your next thought. Okay, plan B. Let me check the countertop next. It's this simple little loop, thought, action, observation, that makes us so incredibly adaptable. Okay, so let's see how this very human process gets built directly into the ReAct framework. It's all about giving this ability to an AI. ReAct, as you might guess, stands for Reason plus Act, and it's a whole new way of getting an AI to work. It prompts the model to generate its reasoning, its thoughts, right alongside its actions. So instead of just spitting out an answer, the model has to show its work. It creates this inner monologue that connects its thinking to what it's about to do. And this creates this really powerful dynamic loop. First, the AI thinks, okay, what do I need to figure out? That leads to an action, like using a tool to search Wikipedia for that info. And then, critically, it gets an observation. It gets new information from that tool, which then feeds directly into its next thought. That whole black box problem, it's just gone. We can see the process. Now, I know this might sound a little abstract, so let's look at a real head-to-head comparison from the research to see what a huge difference this actually makes. Okay, check this out. A standard reason-only model was asked this question about what other device can control the program Apple Remote was originally designed for. And it comes back with this super confident answer: iPhone, iPad, and iPod Touch. I mean, it sounds plausible, right? But it's totally wrong. It's a classic hallucination. The AI just made it up. But now look at how ReAct handles it. This is so cool. Instead of just guessing, it starts with a thought. I need to search Apple Remote. That thought leads to an action. It searches for that term. Then comes the observation. It finds out that the remote was originally designed for front row. See that? That new piece of information immediately informs its next thought. Okay, now I need to search for front row. It's building its knowledge step by step. It's not just jumping to a conclusion. And just to cover all the bases, let's look at the other extreme. What happens with no reasoning at all? Well, an act-only agent can get ridiculously stuck. In this case, it keeps trying to take a pepper shaker from a sink where there is no pepper shaker. And because it can't form a simple thought like, hey, this isn't working, maybe I should look somewhere else, it just keeps trying the same failed action over and over. It's all action, no thought.
So when you see these examples, you start to realize these are truly game-changing benefits. This isn't just some small incremental improvement. It's a fundamental shift in how these AIs operate.
By tying thought to action, ReAct makes AI way more trustworthy because it's forced to ground its reasoning in actual facts it finds. It's way more interpretable because we can literally read its thought process and see exactly why it made a decision. And because of all that, it becomes so much more capable and robust. It can handle complex tasks and, adjust its plan if something unexpected pops up.
And the numbers? Oh, the numbers absolutely back this up. So on this complex task called ALF world, where an AI agent has to follow instructions in a simulated house, the old ACT-only model had a success rate of just 45%. But the ReAct model? A whopping 71% success rate.
Yeah, that's an absolute improvement of nearly 34%. That is a massive, massive leap in performance. And it all came from simply teaching the AI to think before it acts. But honestly, the most exciting part of all this might not even be about making a better standalone AI. It's about what this means for how we can work with AI in the future.
See, because we can watch the AI's reasoning, we can also jump in and help when it gets stuck. So in this example, the AI is trying to find two keychains. It finds the first one, but then it hallucinates. It gets this incorrect thought that the second keychain is in a drawer it already checked. And that one faulty thought makes the whole task fail. But now, look at this. A person can just step in and edit that one broken thought. They delete the hallucination and just gently nudge it, hey, maybe you should look in the dresser instead. And with that one tiny correction to its inner monologue, the AI gets back on track and nails the task. It's amazing.
So the big takeaway here is that ReAct isn't just about making AI smarter on its own. It's really opening the door to a totally new kind of partnership. It turns AI from this black box that we just cross our fingers and hope gets it right into a transparent collaborator that we can actually guide, correct, and work with. And it leaves you with a pretty cool question, right? If we can guide an AI's thoughts, are we just teaching it anymore? Or are we actually starting to collaborate with it in a way we never, ever could before?